Okay, let's get started for third week. Autodesk Revit and BIM-based design. Last week we have learned some BIM approaches for design. Okay, and also we take a look some features in Revit. Today we're going to use Revit, but before doing that, in theory course, let's take a look at a little bit more about BIM and BIM features using Revit. Okay, so here I list up what to do today. Actually, for Revit, I believe that if you focus on what to do, specifically designing this building, I think you can learn just one day. Okay, but we have series of things to do. So today I like to make entire floor, actually not entire floor, this floor, level 5, okay? So you need to submit level 5 for today's lab exercise for entire this level 5. But we have more things to do. So actually I like to let you know what to do, how to do. I believe you're gonna learn Revit and you're gonna find out Revit is really, really easy to use and intuitive. At the beginning of learning BIM using Revit, most people think Revit is kind of very easy and intuitive and powerful and very smart tool. Okay, so today's main objective is to figure out what are these using wall object, door, window, stairwell, space object, and some components such as furniture, door, desks or chairs, and so on. And also floor object as well as levels. Okay, all they are objects, not geometry. So let's talk about a little bit more on that. And also we're gonna walk through, but I think until next week you're gonna get something finalized, this model, this building model, as well as some useful resources based upon this one. Okay, let's quickly review BIM approach. Okay, BIM approach, building information modeling approach. What is the difference between from geometry-centered approach we have walked through before? Okay, again, some quotes in architectural design. They all say something about space, empty space, okay, void space, untouchable. But actually we design space, but we not design space, okay? For designing space, we need to make boundaries, okay? In other words, in conventional CAD systems, two parallel lines for wall object, actually not wall object, wall drawing, okay? And arc and 900 millimeter lines representing a door, because there is a symbol of door object, okay? So instead of walls, windows, doors, ceiling, slab, column, furniture, space, we draw something, okay, on top of 2D. Even if it's 3D, just geometric shapes, okay? So take a look. Architects, they mentioned we are dealing with the spaces. But remember what you have done when you design. Space is void, empty, untouchable. So we made some parallel lines, symbols, notations, bunch of polygons, surfaces, instead of real objects, including space object, okay? But in Revit, in BIM tools, there are such objects, no such geometric points, lines, edges, faces, and so on. Okay, that's one of the fundamental difference between geometric approach and BIM approach. Okay, that's why I showed you this one before. Two representations are not just simple difference between 2D and 3D. If this one can be 3D, and even BIM model can be 2D. Okay, that's okay. But this one is office labeled polygon. Okay. No information. This is just geometry, mere geometry, or so-called dummy geometry. But in BIM tool, there is space object. Its name is office, space name is office. This is label title text is office, okay? Entire geometry we created before is one tiny subset of the information set, okay? But actually the information set, look at this, it's never ending. In other words, open-ended. So far, there is specific definition, okay, defined by someone else, ISO, some industry people, some developers. But you can add anything, okay? It's open-ended. Take a look, geometry-oriented approach, vertex, edge, face, polygon, surface. But in BIM tools, we approach building design using this hierarchical structure, the same as designers and architects are doing, okay? Site building, floor space, space group, and structure, okay? The structure for physical, tangible, and something specific components, okay? Of course, there are some physical and tangible components, but those are some topological, hierarchical, conceptual elements, but they are still in the structure of the BIM. So that's why I showed you this one before. This is the data structure of IFC. Total 653 entities. Entity means one single rectangle box here. Those are just my example, okay? Just 20 entities just listed. How about 610 more boxes, entities? They are all about buildings in very complicated data structure defined in computational model for building. Anyway, my point was IFC site, building, building story, space, space group, and element, building element, and building structure. All they are defined and very, very well defined, well structured in computational model. Why? Simply because computer deals with buildings for human in very scientific and well organized and without any ambiguity, okay? That's why this structure is really complicated. Actually, this one also has point, vertices, edges, surfaces, knobs, curve, and so on for handling geometry, okay? Anyway, this is very distinct feature of BIM approach. And also take a look, data modeling example. Data model, we have object, okay? What is object? Building is one of the object, the bigger object. Floor, space, how about column? How about window? Or just mechanical system, lighting system, or floor material, whatever, okay? They are all objects. And the attributes defined under each object means property. Property and attribute, they are all same, okay? So what kinds of properties? I told you, it's open-ended, okay? Some of them are sort of predefined, user input, okay? For example, space name, you have to type space name when you model space, but mostly sort of calculated, auto-generated, auto-related, and so on. So what if we have amount of information we have? For designers, they can use such information for better design. For contractors, they can use some construction-specific information for better construction. How about managers, facility managers for maintenance? They can reuse given information such as space name, space area, and energy efficiency and occupancy time. And then facility manager can make a plan for saving money, okay? Saving electricity, saving heating cost or air cooling cost, and so on, based upon given information. Who add information? Architects, or even managers, or computers, okay? computer can generate some auto calculation, such as area, height. We don't need to measure area or height. Rabbit knows exactly calculated space area and space height and related words. How many windows this space has, okay? It's automatically detected by computers. Also adjacency or circulation, whatever. So BIM is the way we should go, okay? It takes advantages of advanced computing technologies and it enables us to focus on design, not computing. I show you some quotes, okay? Architects, designers, human beings, main interest is what is good building, what is good environment. Their interest is not on computing itself, okay? Computing is just a tool. But in CAD system, you have to know how to control surface, how to control vertices for my beautiful knobs curve, how to edit editable poly. That was your concern at that time for 3D Max SketchUp, how to make these copies in automation. But that's not about design. That's about computing interface, computing techniques. But in BIM tools, you can keep more focus on design, okay? Not unnecessary techniques. So this is advanced and cutting edge technologies you can use, okay? So actually I showed you a lot before, computing tools, computing technologies. Let's take a review, another review using homestyler.com. I introduced you this one even when you were freshmen, okay? So this iPad or any smartphone or smart tablet application app is very easy to use, okay? You can decorate your room or you can plan any single house, whatever. This is PC version. What you need to do is simply drag and drop and put the dimension, numbers, and place furniture, windows, and so on. Take a look. This is Homestyler web version. This one doesn't require any plugin or ActiveX installation. This is just running on top of your any browser. So take a look. This is 3D view. If you click this door, and then this one pops up information, size. Very simplified attribute, property that I showed you before under the object named door. Under this information, this one shows you double entry door, cherry color, and its dimension listed here. In other words, this is a door object, not door-like geometry. Again, this is BIM tool, okay? This is BIM tool, not CAD system. So thanks to this simple BIM tool, this one can export AutoCAD file and Revit file. This one can be exported in this AutoCAD file. When you click this one, door geometry, information doesn't show anything about door, okay? Because AutoCAD doesn't know this is door. Only it recognizes layer name, layer type, line thickness, lots of things about position X, Y, Z, and Cartesian coordinate system, and something miscellaneous things. But when you export that into Revit and open in Revit and click this door, this one knows double panel door and associated information. But bunch of things are missing because original source of this one was Homestyler, which is really simplified BIM tool. So you can add more information. You can edit, delete, doing something. It's a BIM tool, okay? That's different system. So according to your design process, your idea should be abstract, okay? Abstraction. You need to represent your idea because that idea is invisible, okay? You have to say something in your oral speech about your idea, your design, and then it's going to be represented, recognized by others. But we have our own standard, so-called industry standard. What is our domain's industry standard? They are floor plan, elevations, sections, axonometric, isometric, okay? They are all our industry standard in building industry, AEC, FM industry. Sometimes this kind of bubble diagramming, hand drawing, sketching, and another hand drawing for generating those industry standard, even 100, 200 years ago, okay? So those architectural symbols are our industry standard. So all this process was conventional before computers, but nowadays we use computers. So at the beginning of computing, we used computers for what we have drawn, okay? For drawing. We use computers only for drawing. That is why AutoCAD, SketchUp, Rhino, 3D Max, they all about design visualization and drawings, okay? This is a geometric line object, not door object. But now we're gonna deal with Revit. We're gonna handle BIM tools. In BIM tools, this is door object. It has dimensions, parameters, as well as geometry. Computer doesn't know this is a door, okay? This is really important, distinct feature of BIM tool. Only BIM authoring tools can draw this door, not by general CAD tools for jewelry, textile, machine, and so on. In other words, this is building information modeling tool. Using SketchUp, you can make some fashion design, okay, automobile design. Even you can design space shuttle, okay, 3D Max, game characters, whatever. But using BIM tools, there is no way to design automobile or aircraft or any other type of vehicles or products, okay, only for buildings, because it's literally, as it means, building information modeling tool, okay? That's another big important distinction. Our focus was on geometric shape when we use computers at first. But smart people think about, for building design, we need something smart way, okay? Computing technologies are growing and human demands also growing. That is why this kind of advanced tool introduced 30, 40 years ago and realized around 10, 20 years ago. And now you are learning this tool. And in interior industry, interior design industry, so far, very few people know this, but in near future, you're supposed to use this kind of tools. So far, you have learned this area, okay? Vertex, edge, face, shell. Using what? Modifiers in geometric tools, such as editable poly or bunch of complicated modifiers predefined in 3D Max, Rhino, SketchUp, plugin, and so on. All geometry centered, okay? Some parameters, something advanced, but they are still geometry tools. But think about this part, okay? BIM, parametric modeling. Last week you saw Revit has building project, okay? This is project. What is family? What is object? What is part? This is one simple example of a part. Part, component, family, object, they are almost same, okay? Those things separately designed, defined, and loaded into your project. So adaptively applied for your design project, okay? So this is even smart way, okay? You don't need to take care of complicated geometry when you are modeling, building, okay? If you want to control this geometry, you need to go back to part editor, so-called family editor, okay? So now we're going to take this approach in actual lab exercise. Actually, this kind of advanced technologies are very up-to-date and ongoing. Even more advanced things are all around nowadays. For example, machine learning is very current technology, okay? some of my friends at Georgia Tech, nowadays they are working in Microsoft, Apple, Google, Intel. Someone is in charge of some suggestion system in Bing search engine, and someone is in charge of enhancing Google's some search engine. It makes it smarter, okay? Okay, my question, what if a machine learns building design, BIM, CAD, whatever? Take a look. You know this is a muffin, not a face of puppy, okay? This is a face of puppy, okay? This is muffin, this is dog face, okay? So your mom, your daddy, your friends, they didn't teach you how to differentiate them, okay? You learn how? You learn based upon your experience in your daily life, okay? You learn by your own experience since you were very young, okay? What if you are just 3-year-old boy or girl? You cannot differentiate those two things because based upon your experience, you never seen this kind of muffin or dog face before. Okay, what you have seen, experience was your mommy and daddy, your sisters, your family, that's it, okay? But by the books, by the video, by the animation, you learn every day. That's the fundamental mechanism of machine learning. Google search engine nowadays collect those images every day, not every day, every second. Billions of images uploaded by users from Instagram, Facebook, Pinterest, whatever. What if, even if user upload this picture named puppy or my face, whatever, based upon the pattern the machine, Google machine learned, this one is not a puppy, this one is muffin, okay? Actually, this case is really difficult case, but at least cat and dog, Google can make distinction, okay? Precisely, comparatively, easily, okay? Even if you search, upload cat photo with named a puppy, Google auto-detect that is puppy face, not even if the title was cat. Anyway, that is the mechanism what human beings learn. And in the same way, nowadays, computers learning by itself, so-called machine learning, deep learning, okay? So that is why AlphaGo has won the game against human champion, okay? Isidore. Do you know the meaning of alpha? Meaning of Go? So AlphaGo simply means Go is the most complicated board game, Go. In other words, Baduk, okay? Very complicated game. But this machine has name Alpha. Alpha usually means A, but in software industry, Alpha means initial version, okay? Alpha version, beta version, and official release. So the name AlphaGo means initial software, first software for Go game. Because it learns Go by itself using amount of computing power. No one teach Go game to AlphaGo. AlphaGo learn by itself with autonomy using internet networks, learning skills, techniques, okay? What if Alpha Chess? Actually, there was this machine. Next version of AlphaGo supposed to be Alpha StarCraft. That's what Google said, okay? So StarCraft game champions can make matches with this machine in the future, in near future maybe. How about Alpha Role or something else? How about Alpha Design or Alpha Architecture, Alpha Interior Design? This machine can learn by themselves, learning building designs and interior architecture design, existing entire this world, this planet, using Google. What if your design or existing building designs learned by computers? Can you defeat this kind of machine for design? If there is a subject, okay, Starbucks new branch interior design, and you design, and this alpha design in automation in 10 seconds, who can win? This machine knows entire world Starbucks designs pros and cons, and its merits and demerits, location, size, and so on. Can you defeat this machine? It can design in just, I think, in 10 seconds, okay, with 3D geometry, 3D beam file, whatever. Are you sure you can design better than these machines, those machines? What should you learn and study now? Actually, currently I'm working on some part of this machine, okay? AI-based computer, artificial intelligence-based. Now I'm involved in automation of design rule checking for building permit system of Korea government. And also with ISO, I'm gonna involved in some international standardized regulatory ways on automated design checking, okay? Automated design review. What if we want to make not just design review, automated design tool, okay? Based upon existing design. In other words, based upon experience. Of course, totally new design, not existing on this planet, can be only designed by human. But most of design, I mean, something a little bit different from existing design can be easily and well designed by this kind of machine, this kind of software in near future. Using what technologies? Of course, BIM technologies, okay? So geometric modeling, Google already did, okay, using Google Earth, Google Map. They took pictures and they made 3D geometry for entire this planet. Nowadays, they are working indoor, okay, to build indoor geometry. So they are dealing with geometry. Geometry is not the matter anymore. We need to take care of some more information, more things we need, okay? Computers couldn't understand what it is. They just work and think by itself based upon given algorithm. Anyway, this is one simple and kind of up-to-date issue that I like to bring your attention, okay? Even if there is alpha design, based upon human creativity, we can do a lot more. So what you need to do is, the answer for this one is simply learning cutting-edge design tools and mechanism. In other words, something about BIM, okay? Or even beyond the BIM applications. That's the point, okay? We need to take care of some theories and some complicated issues regarding Revit and BIM tools, BIM tools. Actually, solid modeling, when we say solid model or parametric model, there is a book titled named Solid Modeling, very thick and really, really hard to read, okay? Very complicated. It's not easy to figure out what is solid modeling exactly, but in a nutshell, I like to show you some fundamental and important features of solid modeling defined in Revit, because before I showed you this one lots of times. So far, we have learned those two parts, okay? Drawing, drafting, and surface-based 3D using SketchUp, 3D Max, and so on. But next phase is solid model and parametric model. At the end, current up-to-date, cutting-edge technology is product data modeling or building information modeling. So take a look. We know surface based 3D model. Something like this one, okay? Control vertex using FFD or something similar. You can edit any shape of surface or 3D. That is surface-based 3D because mathematically this one doesn't have thickness. Thickness is 0, okay? But this one is solid-based 3D. Actually, in this visual, just based upon visual, we cannot determine whether this one is surface-based 3D or solid-based 3D. We need to see inside of this definition. But anyway, they are solid, and that one is surface model. This one simply explains you solid and surface-based 3D. Okay, hollow, empty inside, and still solid inside. So SketchUp, 3D Max, Rhino, AutoCAD. Most of geometric tools are totally based upon surface-based 3D because solid model must be well-defined. I mean, ill-defined 3D cannot be existing in this system. In other words, how about this kind of surface? We can design something like this only for visualization. If we cannot define this kind of object, we have to make enclosed 3D or 2D. That's annoying, okay? We need to take care of which one is not enclosed, which one is dangled, or which one is problem. We don't have time if our focus was just visualization. In that case, those are very convenient. For example, game. In game environment, no one cares the game character or driving cars are solid model or surface. Surface also faster than solid model. But Revit, ArchiCAD, they all based upon solid. There is no way to define surface 3D. Okay? Why? Because this one is dealing with real world object, building environment. In real world, there is no such surface-based 3D. Okay? This is theoretical, mathematical, and conceptual definition of 3D, not real definition. This is real. Okay? So by using solid model, what you can do? Solid cube, solid sphere, and solid cylinder, based upon those primitives, you can get this kind of components. Okay? This one looking very complicated, but actually not that sophisticated. Union. Sorry, this one actually intersection. Union, intersection, and minus. And then you can get this kind of solid 3D. If all those are surface-based 3D, this calculation cannot be done or some errors. Okay? SketchUp or 3D Max, you have this kind of solid equation calculation, but it's really error prone, a lot of errors, because it tried to make this kind of operation, but it is not solid, it is just surface. So disguising as a solid and try to operation, but always problem. Anyway, in Revit, every single geometry can be created by this kind of constructive solid geometry operations. Let's take a look examples. This is looking like some construction component, bricks, or some similar object. Section profile, extrusion, okay? Extrusion is the most fundamental way of 3D creation. Solid blend, okay? This shape and another shape creates 3D solid like that way, revolving. Section profile and axis, this object. Sweeping is the most important and very commonly used one, okay? Two section profiles and sweeping. And another smart sweep, okay? Section profile is this one, okay? And your path defined here, but in SketchUp or 3D Max, this one can be created like this way. But in this way, just the surface, okay? And another surface. That's mathematical definition of sweeping. But Revit is, BIM tool is kind of smart. This one turning 90 degrees automatically, okay? And make this 3D. And another turning of 90 degrees and make this solid geometry without any problem. Also, void forms commonly used, box cube and smaller cube, A minus B, easily creates something like this. Also, void blended or void swept blend, void revolve, void sweeping, okay? Box cube and sweeping, okay? Rectangle shape, section profile, and path sweeping going to be extracted. So final output always solid model, okay? Even if it's looking complicated, whatever it is, it's anyway all solid. So very complicated geometry, sometimes really heavy, and solid model, usually file size is very big, and you need kind of fast and expensive computer you need, okay, for handling BIM tools. Okay, let's take a look parametric modeling, okay, another one. To figure out parametric modeling, this is another challenging issue, okay? Parametric modeling is still very cutting edge and up-to-date issues in computer science, mechanical engineering, general engineering area, okay? The term parametric modeling is still growing, still under the development, under the research. But anyway, we need to know what is parametric modeling, at least. So far, we have learned those two parts, but in this semester, we're going to deal with all these together in this class, okay? Solid model contained by parametric model, they all contained by cutting edge technology, building information modeling. What is parameter? Parameter usually means height with steps instead of x, y, z, okay? X, y, z, or just simple length. This one determines the shape of object, not geometry, okay? Something about object. We don't say this door has X, Y, Z coordinate system, something like that, blah, blah. We don't say that. We say this door has 900 width and 1.8 meters height, and it has 5 millimeter thickness glass on the middle of that door and door handle and so on. They are parameters, okay? In other words, something like properties. Okay, for understanding parametric modeling, we also need to know feature-based modeling. It's something like feature sweeping, okay? There is a feature and path. So this solid object is so-called feature-based model. Features are defined to be parametric shapes associated with attributes such as intrinsic geometric parameters. Intrinsic geometric parameters, position and orientation, geometric tolerance, material property, reference, and so on. Not just X, Y, Z coordinate system, okay? So feature-based modeling is kind of initial approach to parametric modeling and BIM. Let's take a look at this chair example. What if this is SketchUp model or 3D Max model? Okay, this is original model of, actually this is really famous design chair. Anyway, this design chair for 1, but we need design chair for 2 or 3. So what you can do in SketchUp or 3D Max, using scale tool, you can select and you can make it broader, wider, for 2, for 3. in that case, take a look. This frame thickness also can be increased, and the side also can be bigger, okay? Because that is geometric operation, not parametric operation. But what if this is parametric model? This one has parameter of width. So width for 1, width for 2, for 3, you can only adjust that width. In other words, the frame thickness or the side thickness, they don't be affected by width of this sitting area, okay? So that is parametric modeling. So what firstly you need to know for parametric modeling is parameters can be modified later with the model updater reflector modification, parts assembly and drawings. This is sort of assembly. Part can be this sitting and frame and side, okay? So you want to edit only this part, and then final assembly going to be affected only by this part, okay? You're not going to touch the frame or side, okay? Drawing. Actually, this one has sketch mode or something else. We're going to learn what is sketch mode today. Another important concept is constraint, okay? Constraint sometimes annoying, okay? If you want to control this one, but there is no way to control the thickness of this frame. If this is 3D Max or SketchUp, you can control anything. But if this is Revit or any other BIM tool, there is no way to control the thickness of frame or thickness of side and so on. You have to go to family editor, part editor, not in project editor, okay? Because it has constraint. And also, think about that. Window object. In Revit, you cannot install windows without wall. You have to install wall first and then place windows on top of that wall object. Because window has intrinsic constraint, it only can be installed on top of wall object. Without wall, it cannot be existing. That's basic constraint of Windows. There are too many constraints. So sometimes you feel tired or you feel annoying. You have no freedom of editing of the model. But at the end, you may understand that is better way, smarter way, and so on, okay? Another reason for using parametric model, take a look this kind of structure, or this kind of column and roof object, or this kind of very algorithmic defined geometry. What if you design this one using 3D Max or Rhino? Based upon your mouse click and drag and drop, this can be designed anytime. You can design something like this using SketchUp or AutoCAD 3D Max. But the problem is that design done by your hunch, by accident, okay? If you drag a little bit more, this design going to be changed. What if you want to recreate this one next day using same tool? You don't know how many drag you need for making this curve line, surface line, okay? Your file already saved, so you can reuse that, but what if you want to change in some scientific and logical way? No way, okay? Totally determined by your mouse drag and drop and mouse click and your procedure of modifiers. No logical approaches. Actually, in backside, computer knows the logic, but your side, you don't know. What you remember is click some modifier and drag to some direction. I don't remember how amount of the distance, but anyway, drag and drop or clicking somewhere, and then you can generate this shape in accident, okay? You didn't imagine the shape before you clicking your mouse, okay? So you need parameters, constraints, and equations in order to be editable, okay? If this one used the function, okay, fx, I mean sine, cosine, curve with specific parameter, and then you can recreate this one again and again. If you change the parameters of this sine or cosine curve, or this sine or cosine curve, or dimension for this honeycomb shape or something else, whatever, you can recreate that one and you can redefine this geometry anytime. So designing by parameters, constraints, and equations in order to be editable, that is much easier than designing by mouse clicks, okay? Sometimes, especially for this kind of freeform shape. Another very important reason is constructability. How to make this one? By your mouse click design, it's okay. It's good representation. But how to make it? Computer doesn't know what is this. Computer doesn't count the number of panels, okay? You have to count one by one on your visual, okay? Number of honeycomb or number of holes, all day, your work, if you design by just the geometric approach. But if you define this one in parametric tool using part and assembly, you know the quantity takeoff. You know the angle, dimension for each component, okay? That's another big difference. And one of your lab exercise in this course, not today, going to be something like this, to create something like those design. And computer tool understands how many panels, how long, different lengths, frame bars you need, and so on. They all can be extracted, computed, controlled by computers. That's another important reason for parametric modeling. Revit basically used the parametric modeling approach, not just geometric editing approach, okay? But some of tools still we need. So in a nutshell, parametric modeling can be defined like this way, okay? That is so-called parametric modeling. Designing by parameters, constraints, equations, editable design. Okay, we're going to have a 10-minute break. We have learned solid modeling, parametric modeling regarding building information modeling techniques, technologies. So why we need such technologies? Why we need to use parametric modeling, BIM tools, BIM technologies, and so on. Let's take a look some non-uniform design of building cases, okay? So those are building designs recently suggested by architect or something realized and mostly still under the development or some ideas only. But anyway, two different ways. It's kind of egg or chicken problem, okay? Based upon human demand for realizing those freeform buildings, parametric design approach has been growing, okay? That's one approach. Another one is, thanks to BIM technologies, computing, design computing, advanced skills, techniques, enabled us to realize this type of shapes, this type of buildings, okay? So I'm not sure what it is, but anyway, one thing clear is that making shapes from fundamental primitive geometry is exactly same to the way of solid modeling and parametric modeling, okay? So it's inevitable trend, okay? Non-uniform, freeform design using parametric design, parametric modeling techniques, and BIM. Take a look. This is one of the preview of Busan, Haeundae, okay? Nowadays, we design building exterior, building skin, building surface, facade using very complicated structure with very organic shape, okay, non-uniform shape. That's inevitable and kind of trend, okay. Let's take a look at inside of the building. This is Dongdaemun Design Plaza, okay, DDP. The inside of DDP. This building has very curvy and non-uniform shape exterior. Of course, that is why this kind of banded angled columns or some rounded ceiling, window structure, everything in this scene kind of non-uniform except flat floor. Okay, for safety reason, of course, floors supposed to be flat, but anyway, very organic shape. Take a look this stairwell and this rail structure and the wall structure. Very organic shaped, okay? How about this one? This is one of the interior design project done by Professor Jang. Jay is working, Mire Medical Center. Take a look this structure. This one is okay. And this building, of course, box shape, modern style building. But inside of this building, there is something like this very unique structure, okay? Non-uniform, freeform, organic shape. So this one, upstairs, stairwell to upstairs, and the other side we can design in this way. So this is one tiny example of some unique design features of interior design. Even if building shape is very simplified using box shaped, anyway, this is an inevitable trend in current built environment design. Let's take a look some more cases, but totally based upon parametric modeling and BIM approaches. Okay. Beito Building and Korea Navy Museum and Plaza Hotel remodel. Take a look this Beito Building. This one located in Garosukil. Okay, very expensive area, and a lot of passengers, lots of young people surrounding this area. But this is, take a look, this building. This is remodel project, just box shape, modern style building. Nothing unique except building facade. So the owner of this building interested in how to make this building kind of attractive for people. There's only one way, okay? This is already box-shaped building. So building facade design alternative can make some distinction from other regular buildings. This is Revit model, okay? Using Revit or BIM tool, this kind of alternative building facade, building skin, container system can be designed quickly, easily, and the same as built. This is picture, okay? Take a look, same. Because this BIM model in Revit supposed to be real structure and all counted, okay? Components, parts, mullions, frames, this container system for entire material or detailed features already predefined in design stage, okay? So this one realized in this way, totally same, okay? If this was just geometry, some design changes or some construction problem in actual construction happened, and that's not gonna exactly same, okay? Because of some actual problems on site. Anyway, one example done by BIM Technologies, and second one, Korea Navy Museum. Take a look. This non-uniform shape already designed by Maya and Rhino, okay? So this is geometric shape, just the geometric shapes sketch at the beginning of the project. But this shape can be imported into Revit, okay? In Revit, designers can put some control vertices in order to edit this triangular shape for the building surface. And then in actual construction, on-site workers can figure out this triangular shape of this building skin facade can be manufactured, delivered to the site, and where to install this part. Okay, this is part and assembly approach we roughly reviewed in parametric modeling approach in BIM. Okay, take a look. The last one, Plaza Hotel, located in front of Seoul City Hall. This is before. Okay, very typical building facade for these hotel rooms. This is under the construction scene. There is a roughly visualized preview, and this is after. Okay, actually it's not easy to figure out one single panel, one single component for one single Windows system. They all different. Okay, take a look this one. The 4 points thickness, depth, geometry has different dimension. So if you see this one, you can find out it has some different thickness or depth. Okay, if this one, I'm not sure the number of this one, but estimately around, if this one has 200 systems, total 200 different modules. Okay, so all they supposed to be precisely manufactured and delivered and to be installed. Okay, so without BIM or parametric modeling technologies, this one going to be really hard work on site. Okay, because no one knows which part going to be installed where. Okay, but thanks to this kind of parametric modeling and BIM approach, successfully done. Okay, like this way. Actually, I'm not talking about the impact of this design, whether this design is good or not, but anyway, different window system, different frame system, all totally different, manufactured at factory, transported and installed. Okay, in order, thanks to parametric modeling and BIM technologies. Also, interior of this hotel totally renewed. Okay, remodeled. Also used BIM technology. Okay, even 5 years ago. Okay, done by Gansam Architects and some other companies. Okay, that's what happened. Just the tiny cases we can take a look. Let me show you another very old and typical project done by United States, an early pilot project using BIM. Okay, this is one of the training building, kind of school-like, very simple structure building. Okay, very commonly found building structure in the United States. Almost more than 10 years ago. Okay, but this building, take a look. It's floor plan, just a rectangle shape. Okay. If you are interested in early phase of architectural design, our focus was on just geometric shape of this building, just a rectangle shape. Okay, 2-3-story building. That's it, and some interior. But I told you before, BIM is in charge of entire building life cycle, from planning until demolition of this building, including several decades of maintenance, management. So interior design or conceptual design, design development, it's really tiny part of life cycle. How about construction? How about mechanical system, plumbing system? Installing such building systems, just tiny part of entire building life cycle. How about maintenance? Maintenance people supposed to be well known to mechanical system or any other building systems. So in terms of building information, BIM is in charge of entire building life cycle. So even if you are just designer, or even if you are interested in only for interior design or structural design, BIM tools in charge of entire building life cycle. So in this process, you can find out structural elements, structural foundation, MEP system, HVAC system, and so on, interior features, and so on. So exterior walls can be visualized like this one, planned, okay, and some structural foundation and H-beam columns, okay, for sustaining the structure of this building. And they can be connected by those using those beams. Additional truss for ceiling structure, and first floor's interior walls and some interior columns, and take a look, mechanical system, so-called MEP system. MEP system means mechanical, electrical, and plumbing, okay? And HVAC system, HVAC system means heating, ventilation, and air conditioning. Without such systems, building cannot run, okay? Walls, columns, slabs, furniture, that's not the end of building design. Amount of such systems usually going over ceiling structure, okay? So when you see open ceiling system, open ceiling room, you can find the amount of pipelines or mechanical systems installed. They are all controlled by some mechanical room or other facility equipments and so on. They all controlled by this kind of BIM tools without any problem. So around 10 years ago, Revit has separate versions. Autodesk Revit architecture, that was design tool, okay? And Autodesk Revit MEP, mostly in charge of building systems. Also another one, Revit structure. Revit structure in charge of structural modeling and analysis for kind of structural system of the building. Load-bearing walls, load-bearing columns, that's their major topic when they use such tools. And they all integrated into Revit architecture or Autodesk Navisworks, another system supporting BIM tools. Okay, anyway, second floor's entire interior walls and doors subcomponents. So truss system for rooftop and final roof object can be installed. The visualization is not that fancy. This is just axonometric view, but isometric view, but this one contains lots of information compared to photorealistic design specific model. Design specific model doesn't care any of this truss structure or sustaining structure, load bearing system, MEP, HVAC system, only deals with interior walls and design features, but actually this one doesn't have interior design features or interior components, furniture. But anyway, even much rich information, lots of information added on top of this single beam model, okay? That's the point. So this pilot project simply shows you some longer and broader scope of building life cycle than schematic design or interior design. So we need to know this kind of process. Another review about Autodesk Revit. Its BIM approaches and use scenario for interiors. Okay, as of 2016 is the latest version, but in general, in May or even April, next year version going to be released officially. So Revit 2017 probably going to be released next month or in May. But anyway, our scheme in this semester, this course, we're going to use Revit 2016. Another one, how about Revit 2025, 10 years from now, 9 years from now. That Revit going to have auto design tool, okay? If you open empty Revit file and you just type, okay, new Starbucks branch located Seoul, Seongdong-gu, and area estimate 100 square meters, and users, target users, young people, and then Revit going to make auto design, just for your information. And what you need to do is adjust. And how about decoration? Okay, I like to put yellow colored flower-like structure in very simple and modern style, and click, and then such geometry components going to auto created in Revit environment, thanks to machine learning and AI techniques. And I'm the one of developers for researching and developing such tools in the future. But anyway, computer cannot determine or make final decision, and computer doesn't have any responsibilities. Thanks to that fact, still designers, architects required, needed, because you have responsibilities for your design. Anyway, anyhow, even if such easy to use tools are available to public, you have to know the mechanism, and you have to customize, and you have to design easier and in convenient way, but at the end you have to determine the final decision and take responsibilities for your design. That is why you need, even if Revit 2025 has such very advanced artificial intelligence features. Anyway, today lab exercise we're gonna use this one, and in my belief, today's lab exercise, 1.5 hour lab exercise, that's enough for learning Revit, because Revit is easy to use. So you can design anything based upon today's lab exercise. Anyway, interfaces we reviewed before. This building, level 5, AutoCAD drawing will be given to you. You already copied, okay? So what you need to do is open Revit, import CAD file, and draw walls, doors, placing windows, only using given components, not custom object. You don't need to download or create anything, just to use existing library. And then you can make this kind of structure today and next week for the lab exercise, okay? These are the interface we reviewed before. One thing you need to remember is the location of template or library. On the C drive, there is program data. This is usually hidden folder. So you have to unhide hidden folders in your folder option, okay? If your computer doesn't list up program data folder. Under program data, there is Autodesk and Revit 2016. Under this folder, you can find out template, library, and so on. Under library, in current installation, we have amount of Korean libraries and generic libraries. If you want to install US metric library or even French, Hungarian library, you can install. Just double click again, Revit installation, and then Revit installation will ask you to add library or not. So you can simply add libraries, okay? Several gigabytes, so it's up to your decision. But so far we have amount of Korea library, so we're gonna use that. So this is the interface we already reviewed. We're gonna do that again in lab exercise, and the mechanism. Another thing you need to know is this is dynamic interface. It has dynamic interface. That means if you select something or click something, new ribbon interface will be popping up like this. Okay, if you click door, this one will show you something about doors and modification for doors, okay? So whatever you want to do, don't just look at screen, just click or doing something, and then this one will display you for further work, okay? Property windows, project browser, we already reviewed. Let's take a look some key features of Revit. Firstly, you can export building geometry in DWG, DWF, FBX. FBX contains Autodesk material, texture. So you don't need to texture again and again in 3D Max. You can render without any additional efforts. Anyway, exporting geometry is okay, and also vice versa, importing geometry. Revit supports amount of diverse kind of geometry, versions, formats. It can import almost everything. And also exporting building information model in IFC format. IFC is one of the file format, okay? Neutral file format. So you don't know ArchiCAD. You don't know Bentley systems, but you know Revit. But you're a collaborator working with ArchiCAD, and you need to export exterior surface system of your building design. Just you can export IFC, not DWG. DWG contains only geometry, but this one contains properties, information, parametric data, okay? So your BIM model can be exported through IFC and imported into another BIM tool. What happened? He knows your door object, wall object, corner system object, not just geometry, okay? So this is another important thing, but in undergraduate level, we're not going to deal with IFC format. Instead, I'm going to show you some example cases. I told you before, some cuts in architecture, space-oriented approach. We are dealing with space. But in CAD system, there is no way to define space. There is a way to define walls, bounding walls. And then we can recognize that inside of bounding walls going to be going to be space or room. But in Revit, there are space objects such as rooms, floors, zone, and so on, area. Also mass object, okay? Even if just a simple box shape, that is a mass object, okay? You can divide mass for levels, and you can edit that mass to specific building design, okay? And also space object, auto-determine the boundary of space. And you can assign space object. And then you can get the area of space, height of space, how many spaces, how many rooms in your building. Revit can count instead of you, okay? Very smart. And also, how about 2D plans, 2D drawings, 2D draftings? You don't need to take care of them, okay? Floor plans, elevation sections, 3D views, rendering, any type of industry standard or subject of auto generation, okay? You don't need to take care of such views. Of course, you need to take care of some notation, additional notation or some frames and your text, but that's it. Drawings from model auto-generated in auto updates. Building modeling objects and geometry in advanced parametric modeling technologies. I told you what is parametric modeling. Thanks to parametric modeling, whatever you create, all your projects going to be managed by parametric way. In other words, smarter way, okay? Supporting .NET-based plugin development. Actually, this one is something for developers. .NET means Microsoft programming environment, such as C# language, similar to C language, okay? And also, I told you before, usually conventional CAD tools are very powerful for visualization, but I think Revit is much better than other tools in terms of visualization, photorealistic rendering, or this one supports walkthrough video making, okay? Video file, very easy to create. Just save video walkthrough. What you need to do is working paths. And this one will generate animation of walkthrough animation. And bird eye view or any type of 3D view, realistic rendering or line drawings, perspective, isometric, whatever it is, it supports various and diverse kinds of visualization styles. So those are mass object. Another mass object defined by levels and interior fields with Cottonor system. Actually very easy. Design from mass. When you design a building, usually we get started from building mass. Cut building mass, distorting building mass, doing something using that building mass. Same way, okay? In building, you can create building mass first and modifying, just like a sculpture, okay? Same way. And also this is space object. You don't need to do lots of things. What you need to do is simply click room and mouse over the room and then take a look. These blue lines auto-detected boundary of this room, okay? Auto-detected. Just simply click it and name the room. That's it. Render example, another render example in terms of visualization, and FBX file or geometry-based render using Revit model and 3D Max visualization. But Revit render is kind of exceptional when you use Revit render tools capability like this way. Okay, so now we're going to move to the lab exercise, okay?